Hello everyone. Right now we are doing the Lab E3 part 1. This is the circuit we built, and we made a state diagram based on the FF input function, and this is the state sequence that we built. The outermost layer, this one, is actually the basic state sequence, while the two in the middle is the transient state sequence. The difference of red color and blue color direction is this: KA, KB of the JK flip-flop, both 0 will be indicated by the blue color arrows, and KA, KB equals to 1 will be indicated by the red color arrows. So right now, for our circuit, we have built a switch, and this switch is for the clock, while this switch is the KA and KB. So without light and without pressing, it will be 0, and when I press, it will be 1. So now the state we start at 0, 0, 0, this 3, 0, 0, 0. So when I press 1 as KAKB, it should go to 0, 1, 0, and this is the state. Continually, I press again, it goes to 1, 0, 1. Then continue 1, 0, 0, 1, 1, 0, 0, 0, 1, and finally back to 0, 0, 0. And this is the basic loop. However, we still have a 1, 1, 1 and 0, 1, 1 as a transient state. So in order to get inside the transient state, we will have to use 0, 1, 1 to get inside 1, 1, 1, or later 1, 1, 0 to get inside 0, 1, 1. And now I'm going to test the blue direction starting from 0, 0, 0. So KA and KB is 0 now, and when I press, it will go to 0, 1, 0. And because, as we said, the direction will be goes into 1, 1, 1, and now we are going to test it. See, it will become 1, 1, 1. So after that, when it goes into the transient state, it will loop to 0, 1, 1 and back to 1, 1, 1. So in order to go off the loop, we will need to use the red color direction, which means KAKB as 1 at 0, 1, 1 to reach 1, 0, 0, or 1, 1, 1 to reach back 0, 0, 0. So now I'm testing 1, 1, 1 back to 0, 0, 0. When I press KAKB equals to 1, it goes back into 0, 0, 0. So now I will go to this state, which is 1, 0, 1, and I will test KAKB equals to 0. The state diagram states that it will loop back to 1, 0, 1. And this is what happened. When I press the clock, it reads and it loops within 1, 0, 1. So now I'm going to test 1, 0, 0. As stated just now, when KAKB is 1, it goes to 1, 1, 0. And now we are going to test KAKB 0, it will still go to 1, 1, 0. And the result is true. Right now, from 1, 1, 0, I can go back to 0, 1, 1 transient state when KAKB is 0. So this is it, 0, 1, 1. So right now I'm testing again from 0, 1, 1 and back to the basic sequence. When I press KAKB equals to 1 and the clock reads 1, 0, 0. So finally, I'm going to this state to check the loop of KAKB equals to 0. It will loop within the 0, 1. So right now we are in 001 state, and no matter how many times I press, it will still read 001. So currently we have finished up all the state diagram, and the final explanation is the clock actually reads the input when it's rising edge. So the moment I press from 0, the clock changed from 0 to 1, and that is the time it reads the circuit input and provide us with the output here. So thank you very much. Hi everyone, we are now doing Lab E3, part 2, question 1. This is the circuit that we built, and the function will be an 8-bit light chaser. So the output should be 7 LEDs lights up and 1 of the LED off, and it will follow a sequence from 0, 1, 2, 3, 4, 5, 6, 7, 8. Then after that, it will reset back to 0.
0, 1, 2, 3, 4, 5, 6, 7. Okay.
So this is the output, and the result is following the function. And thank you.
Stop. Try to stop it. No. Stop it.
So we have stopped because just now this will be the counter. Once we stop the counter, the counting stop. So when I press it again, then only it start counting back. Thank you. Hello everyone, we are now doing Lab E3 part 2 question 2. The function provided is when the binary is 3, 4, 5, 6, 8, 10, 11, 13 and 14, the output should be 1. Other than that, it should be 0. So start at the beginning, 0, 0, 0. The function is the output is 0. So now we are testing straight away to output of 3. So output 3 is 0, 0, 1, 1. So it lights up. Output of 4 is 0, 1, 0, 0. 5, 6, it still lights up. Then we will go to 8, which is this 1, 0, 0, 0. Then it will be 10, 1, 0, 1, 0, 1, 0, 1, 0. Then will be 11, later 13. 13 is 1, 1, 1, 1, 1, 1, 0, 1. And finally 14 will be 1, 1, 1, 0. So all the outputs execute as we expected. Other than that, will be 1, which is output 0, 2, output 0, and 7, yes, output 0, then 9, output 0 as well, 11, 12. output 0, and finally 15, output 0. Thank you. Hi everyone, we are now doing Lab E3 part 2, question 3. The function provided is when it is 0, 1, 3, 6, 7. In this binary number, the output is 0. So in other words, when the binary is 2, 4, and 5, the output should be 1. Means it lights up. So this is the binary number switch. So starting of 0, 0, 0, which means 0, the output is 0. When it is 1, output is 0. When it is 3, the output is 0 also. When it is 6, the output is 0. And when it is 7, so everything lights up, the output is 0. So let us test the another side where 2 should be the output of 1, 2 output 1, then 4 also output 1, and last 5 is output 1 also. Thank you.